I want to talk to you today about Caribbean coastal ecosystems. They have suffered tremendous damage and loss over the last few decades from direct human activities related to overexploitation, pollution, and even complete removal. I want to talk about these coastal ecosystems in Jamaica, specifically our actions to reverse the loss and the damage to our mangroves, seagrasses, and coral reefs. This is really about greening, or more correctly, regreening, because it's about the damage that we have done to these systems and the fact that we need to fix them. Because although compromised, these coastal ecosystems are critical in the fight against climate change effects, and they still offer protection against the capacity to recover and the capacity to recover against the ravages of climate change. Mitigating their destruction and loss is very important because Jamaica and the Caribbean has as much as 75% of the population living in the coastal zone. And in fact, if you consider the coast as being as far inland as where the effects of the sea is felt, the entire island is coastal. So, mitigating through coastal ecosystem rehabilitation has convinced us that we have the ability to adapt. And it depends on having healthy coastal ecosystems. And so the University of the West Indies and its partners have researched approaches, effective approaches to mangrove ecosystem rehabilitation. Our efforts began in earnest in 2008 when we started our first coastal plant nursery for mangrove seedlings, and a second nursery was started in 2011. These were at the university's marine laboratories. Combined, these nurseries can produce up to 20,000 seedlings, and the seedlings are acclimated, so they're appropriate for the conditions in which we need to plant them. But also in 2008, we benefited from a workshop by the late Robin Lewis III, and here we had real hands-on exposure to mangrove rehabilitation. So now we have our own mangrove rehabilitation expert, Mr. Camilo Trench, and we take a particular approach. We first have to survey the mangroves to see what caused the damage and loss, and this can take the form of aerial surveys, historical maps, Google Earth images, as well as on-the-ground surveys. And that allows us to prescribe or to apply particular approaches to the restoration. In many cases, our approach simply requires removing blockages to water flow. And these blockages, you will not be surprised, can include mounds of garbage compacted over many years in the forest, wood, downed trees from hurricanes, and marl, construction material, dumped in the middle of a mangrove forest in order to reclaim land, usually for squatting. And there are too many of these examples around the island. So by removing these blockages, we are simply restoring the water flow and allowing the mangrove to regenerate and to regreen itself. We're simply fixing the damage that we have done, and the conditions that the mangroves need to thrive will return. In fact, seedlings from adjacent healthy mangrove forests usually repopulate the degraded forest, and it regreens without the need for planting one nursery-reared seedling. But for all these efforts, we realize we have successfully rehabilitated a mere 8 hectares of mangrove forests across Jamaica. And because we know that mangroves can remove carbon dioxide 100 times faster than terrestrial forests, we are very interested in scaling up our efforts. Last June, in that regard, the Inter-American Development Bank signed an agreement on mangrove rehabilitation with the UWI's Solutions for Developing Countries, or SODECO. And that will see 3,500 hectares of mangroves being rehabilitated in south central Jamaica. This will increase Jamaica's mangrove cover by over a third. I'm really looking forward to this. Moving on to seagrasses. The first thing I have to tell you is that we don't actually know how much seagrass we have. We know they grow on shoals and shallow marine areas and will extend deeper if there is enough light for the grasses to survive. These marine grasses are higher plants and they live completely submerged. They're very unusual. They live completely submerged underwater. So it's not always easy to see what is happening to them. We do know, however, how much is being lost from direct removal through hotel and beach development, and these are permitted activities. We also know that excessive shading from overwater bungalows and hotel rooms, which are suddenly becoming extremely popular, these result in loss of seagrasses. We also know, unfortunately, that we have not mastered the techniques to develop effective seagrass nurseries or to adequately transplant threatened seagrasses to an area where they can do better, a more suitable habitat. So we have attempted seagrass nurseries at Discovery Bay with limited success. We tried the dominant species Thalassia, because it dominates most of our shoals in Jamaica. And we found the grass grew too slowly because we think insufficient light in the nursery. And the outplants suffered excessive grazing. As soon as we put the nursery-grown plants out, they were immediately grazed. What we did find during those years, however, is we identified an innovative way to repair the eroding edges of seagrass beds. We call it seagrass sandbagging. The bed of the seagrass will erode if it suffers anchor damage or propeller damage. Sometimes in the middle of the bed will go white, and we call these halos. These will extend and fragment and destroy the bed if they're not fixed. So our innovative sandbagging technique required pinning bags full of sand and seagrass and mulch to the edge of the bed. And the grass actually grew through and over the bags because what you're doing is raising the level of the bed so the seagrass can grow as it normally would. Again, we're just fixing the damage that we have done and the system will regreen itself. So I want to talk about coral reefs. Coral reefs are not green. They do not pull CO2 from the atmosphere, but they're extremely important. And we have dedicated most of our time at the Discovery Bay Marine Laboratory since its founding in 1965 to this study of coral reefs. We have unfortunately watched as Jamaica's coral reefs suffered overfishing, eutrophication, hurricanes, diadema die-off, and more recently, mass bleaching and disease from climate-induced changes in the sea. And so we are convinced that we need to do something about coral reef rehabilitation. So they don't sequester carbon, but the reef is the first line of defense in the Caribbean and Jamaica against coastal erosion from hurricanes and storms. Furthermore, the value of a healthy reef to our economy to support fisheries and tourism is unquestionable. But reefs are not easy. We were challenged to effectively restore and rehabilitate these ecosystems dominated by a tiny, delicate animal that grows extremely slowly, sometimes as slow as 5 millimeters a year, and secretes this rock-like structure that you call a reef. We started with a workshop, and through this workshop, we trained and inspired notable coral reef rehabilitation experts like Dr. Andrew Ross and the late Peter Gale, Jamaica now has over 20 different coral rehabilitation projects, many associated with our fish sanctuaries and protected areas. Most use the approach of coral nurseries, where the corals are actually grown from tiny fragments until they're large enough to be planted out onto the reef. It's a kind of head starting. But in some cases, the actual reef framework has been lost, and so we're just left with the sand. We have to therefore erect structures like reef balls, biorock frames, the star-shaped eco reef, as well as the Acropora iron reef developed in Discovery Bay. And these structures support the reef fragments, and we do the outplanting on them. But there are two recent projects that I want to highlight at the Discovery Bay Marine Lab. The IDB funded us to select resilient corals. These are individuals that survived bleaching, eutrophication, disease, sedimentation, when their immediate neighbors had succumbed. And so these were selected, propagated, and put out on the reefs. The focus was on the massive, slower growing corals, and we were literally being outpaced by the algae using these corals. So the second critical project involved speeding up the growth of these massive corals. And so we adopted the moat microfragmentation technique, and we grew corals really from very tiny fragments in the lab. Essentially, the coral put a lot of effort into regaining optimal size, and so it grew a lot faster. But even as we scale up and speed up our rehabilitation attempts, many argue that there is little chance of success if we put back these species into eutrophic, overfished, diseased, and climate-compromised conditions. And so this is why I believe in a more holistic approach to coastal rehabilitation. I believe we should invest in marine protected areas, call them marine parks, fish sanctuaries, but these bring together the collective efforts of the scientists and government with the end users, the fishers, the tour guides, the hoteliers, for really a more effective and sustainable coastal rehabilitation. And it also supports wise use of the resources. So the marine protected areas also facilitate environmental education. And this transfer of knowledge is in both directions. Many of Jamaica's 18 fish sanctuaries demonstrate this principle of partnerships that lead to effective regreening. But everything has a cost. What you have to balance and consider is the cost of doing something versus the cost of doing nothing. All these activities cost millions of dollars, but you have to consider the tremendous cost of doing nothing. The Commonwealth Marine Economies Program estimated the cost of the Caribbean not adapting to climate change, doing nothing, as 21.7% of total GDP by 2021. So we have to invest in our future and invest in our natural capital. Tourism reaps very high benefits from coastal ecosystems. Hoteliers and others must see the maintenance of the mangrove, the seagrass, and the coral reef near their property as important as maintaining their pool and the hotel buildings. I end with a quote from former Secretary General of the UN, Kofi Annan. It is often said that protecting the environment would constrain or even undermine economic growth. The fact is, the opposite is true. Unless we protect the resources of the Earth's natural capital, we shall not be able to sustain economic growth. And I add, we shall not be able to survive the ravages of climate change. I thank you.